Hello, my dear students. This is Felix Balaji. Today, let us discuss a problem based on electric charges and fields. In this, it is given a solid sphere having radius r and a uniform charge density rho has a cavity of radius r by 2 as shown in the figure. So, it is the sphere having charge density rho and has a cavity of radius r by 2 given. Now you are asked to find electric field at A and electric field at B, the ratio of magnitude of electric field at A and B he was asking. To find electric field at A, find electric field due to whole sphere without cavity at this point. Now due to this sphere, find electric field at the same point. From total field E1, if you remove this part electric field E2, then you will get electric field with cavity at A you will get. Similarly, we have to do for B also. To solve this type of problems, you should know the basic concept. For a sphere, outside electric field formula will be like this. 1 by 4 pi epsilon naught q by distance square. On the surface electric field formula is 1 by 4 pi epsilon naught q by capital R. Inside point electric field formula is 1 by 4 pi epsilon naught q small r by r cube, where small r is the distance from center. If you are asked to find electric field at the center of the sphere, then small r becomes 0, field becomes 0. Using this concept, we will solve this problem. Now, let us find electric field at A. To find electric field at A, due to full sphere, electric field at A will be, let us take E1. At the center of the sphere, electric field at A will be 0. At the same point A, due to this small sphere, let us find electric field. For this small sphere, this A is on the surface. So here electric field E2 let us name. So E2 will be equal to, on the surface, electric field formula will be 1 by 4 pi epsilon naught. Let us assume the charge of the small sphere is small q. Q by radius square. Radius is here r by 2 whole square. So now E2 becomes now 1 by 4 pi epsilon naught. So this becomes 4q by r square. So here small q value actually we don't know. Let us use density concept. Density is given. Density equal to, for total charge q by volume formula 4 by 3 pi r cube. From this, if you want, we can find capital Q value. Rho into 4 by 3 pi r cube. Similarly, use density concept here also. So for this small sphere, so density equal to charge q by volume 4 by 3 pi r by 2 whole cube. So small charge will becomes rho into 4 by 3 pi r cube by 8. Instead of small q, substitute this one. Instead of capital Q, you can substitute this one. Now, what happens to E2 value is 1 by 4 pi epsilon naught 4 by capital R square, small q value rho into 4 by 3 pi r cube by 8. So we can do further simplification. 4 pi cancel. Let it be. This is E2. This is E1. So once again for you, E1 is the electric field due to whole sphere. E2 is the electric field due to small sphere. From the whole sphere, if you remove this part electric field E2, you will get electric field with cavity. Actually we want for the whole sphere, so it is the cavity. Due to remaining charge, here electric field I want. So net electric field at A will be equal to E1 minus E2. So E1 is 0, we know. E2 value rho r by 6 epsilon naught. So from this I can find EA magnitude. So remove minus rho r by 6 epsilon naught. Similarly, we have to repeat with B also. Now, due to full sphere at B, electric field formula let is named as E1. So, for this sphere, it is on the surface electric field formula 1 by 4 pi epsilon naught. Here, charge is Q by R square. So, we know already charge value, we have derived it. So, this is density into volume 4 by 3 pi R cube. So in place of Q, substitute rho into 4 by 3 pi R cube. So what you will get is E1 equal to 4 pi gets cancelled. So we got rho R by 3 epsilon naught. So this is E1. Similarly, for the small sphere at the same point, for this sphere at the same point B, here electric field I want. This is R and this is R by 2. From this center to this point electric field will be R plus R by 2. This becomes 3R by 2. So due to small sphere at 3R by 2 distance, here electric field I want. So E2 is the electric field outside of the small sphere. Formula becomes 1 by 4 pi epsilon naught Q by small r square. Here small r value was 3R by 2 whole square. And charge of this small sphere is small q. So this q value was rho into 4 by 3 pi r by 2 whole cube, that means r cube by 8. So now E2 value was rho also will be there. E2 value becomes rho r by 54 epsilon naught. Now sir, E2 is the electric field due to small sphere at point B. So now final electric field at B will be equal to, due to whole sphere electric field is E1, due to small sphere electric field is U2. If you remove E2, you will get electric field with cavity. So E1 value rho r by 3 epsilon naught minus E2 value rho r by 54 epsilon naught. So electric field at B will be equal to rho r by 3 epsilon naught into 17 by 18. So now you are asked to find the ratio of magnitudes of electric field at A and B. This ratio they are asking. Already we got EA value as rho r by 6 epsilon naught. Rho r by 6 epsilon naught. EB value was rho r into 17 by 3 epsilon naught into 18. Now you can simplify. Rho r epsilon naught cancel. Epsilon naught cancel. Even by 6 here 3 times. So your answer is 9 by 17. Thank you.